So today we're going to take a look at finding an equation of a line, section 3.4. Our objectives are going to be to identify point slope form and slope y-intercept form of a line, to find the equation of a line given any of the following: its slope and a point, its slope and the y-intercept, or just 2 points. And finally, we're going to determine the relative slopes of two parallel lines or two perpendicular lines. So we begin with point slope form. And as some of you may know, point slope form is defined as y minus y1 equals m times the quantity x minus x1. Now the key points to notice here are the following. This x1 and this y1 is a point that you're given in the problem, and m is the slope. So again, x1, y1 is a given point, and m is the slope. And we'll do an example with these in a moment. The second form we're going to look at is slope y-intercept form, which tells us y equals mx plus b, where in this case, m is the slope and b is the y-intercept. And what do we mean by that? Well, m again is the slope, 0 comma b, really, alright, is the y-intercept. Because remember, for the y-intercept, x is always equal to 0. Let's take a look at an example of this. Example 1 says to determine the equation of the line through the points 2, 4, and negative 3, comma 7. Express your answer in standard form. So what I'd like to do is to take a look at both ways to solve this. First using point slope, then using slope y-intercept. So let's start with point slope. Well, we have a point already. We have 2 points, it looks like. So if we have 2 points and we don't have a slope, we should start really by finding the slope of the line. So let's go ahead and preface this with, let's find the slope of this line. So remember, the slope is the change in y over the change in x. When I do this, I see 4 minus 7. Well, that's going to give me negative 3 up top. And then after that, I do 2 minus negative 3. That's going to give me 2 minus negative 3 is positive 5. So it's going to be a positive 5 here. So the slope for this one is going to be simply negative 3/5. At this point, we can go ahead and just plug in one of our two given points. We're given the point 2, comma 4, and we're given the point negative 3, comma 7. It really doesn't make any difference which one you plug in because they both are on the line. So, just for the sake of simplicity, I would plug in 2, comma 4. So we get y minus 4. Again, the 4 is y1, and the 2 is x1, equals negative 3/5 x minus 2. And then if I want to put this into standard form, I could realize right away, well, you know what? I need to get rid of a 5 because there's a 5 in the denominator of the slope. So multiply the entire equation by 5 on both sides. Cancel, cancel. This becomes on the left-hand side 5y minus 20, and on the right-hand side negative 3 x minus 2. Distributing the negative 3, we're going to end up with negative 3x plus 6. Now if we want to put this in standard form, it should be ax plus by equals c. We can move the 3x over by adding it, and move the 20x or the 20 over by adding it. So let's add 3x to both sides, and then let's add 20 to both sides. These cancel, yielding a solution of 3x plus 5y equals 26. Again, here's the solution for the equation in standard form when we started in point slope form. Now let's start in slope-intercept form. We know the slope again, but slope-intercept form says the following. This is the second method to solve this. The slope we had a minute ago was negative 3/5, so we can start already by putting negative 3/5 in here. Then we can simply say to ourselves, well, we have x comma y. That's the point 2 comma 4, so let's go ahead and just plug in 2 comma 4. So plugging in 2 comma 4, remember that x is 2, so the 2 is going to go here, and that y is 4, it's going to go here. And we could solve for the b value in this problem. Okay, and in doing so, what we'll end up getting here is b is going to become 26 over 5. I'll leave that to you to solve on your own. You're going to have to move over your fraction to get 26 over 5. Remember, please, that you need a common denominator to add fractions. So if b is 26 over 5, we now have an equation that says the following. y equals negative 3/5 x plus 26 over 5. Well, that's really messy. It's correct, but it is messy. What we can notice, though, is that if we want this in standard form, like the problem asks for, let's just multiply everything by 5. I'll put a 5y here, and it'll drop off the 5's on the other hand. And then add the 3x over to the left-hand side, giving us 3x plus 5y equals 26. The same exact answer we had a moment ago. 3x plus 5y equals 26. So either way you do this problem, you're going to end up with the same answer. Now, it really doesn't matter what form you use to represent the equation of the line, but it does matter when you use it in applications. For example, we've been looking for the solution in standard form, but maybe the solution in y-intercept or slope-intercept form is the better way to look at it sometimes. Like for example here, if I left it this way, I could see that we have our slope, we have our starting value, or the y-intercept. So on a graph, I know already this is around 5, like 5.2. So I go up 1, 2, 3, 4, 5. So I'm starting here, and I've got a slope of negative 3/5. So down 3 over 5, so slope of negative 3/5 through my y-intercept there at 5.2. Well, this tells me, by looking at it this way, the following. Imagine this was like, let's say, a resource, and we were looking at it and we were saying, we start with a certain amount of that resource, but over time we deplete that resource. So say you were looking at like uranium and you're working in nuclear physics. You have a certain amount, but over a certain time it's going to decrease the amount you have. So you might want to know what your starting value is and the rate at which it decreases. So sometimes it is important to leave it like this. Or maybe like a cell phone plan. There's a basic value every month of, a charge of $30 a month. Plus the amount of minutes you use is your rate. So you have a starting value, but then the cost will go up as you use more and more minutes. So it's good to know that this is your rate and this is your starting value. So maybe we should jot that down. Starting value and rate of change. Okay, so the next theorem states the following. If L1 and L2 are two different lines with slopes M1 and M2 respectively, then the following two things hold true. If L1 and L2 are parallel, then their slopes are equivalent. M1 is equal to M2. And this makes sense. Think about two parallel lines on a graph. Here's one line. Let's draw another line that's parallel to it. Their slopes are identical. They're both rising at the exact same rate. But if we take a look at an example of two lines on a graph that are perpendicular, here's one of them, here's the other one of them, we're going to see clearly if one of the slopes is positive, the other one must be negative. Well, let's look at our second condition here. It says that if L1 and L2 are perpendicular, if the product of M1 and M2 is negative 1, and that means that they are negative reciprocals. Take a look and solve. Solve for M1 in this equation. You would divide by M2, and divide by M2, giving you this right here. M1 is equal to negative 1 over M2. So we could say that perpendicular lines have negative reciprocal slopes. Example 2 tells us, let P be the point 2, negative 6, and L the line 3x minus 4y equals 8. Find an equation in standard form of the line L1 through point P and parallel to L. And then part B will do the same thing, but it'll be perpendicular. So let's start. Here's our original equation. And for this equation, we can start by finding out what the slope is. So let's take a look. If I want to find the slope of this, I don't want to have to go through all the work to find the slope. So instead of doing that, I could just use negative a over b. Negative a over b. So the slope is simply 3/4. So now I've got the slope of our original line up here. We know that L1 is going to be parallel to that. So let's write down some things. So for L1, we know that the slope, M1, is going to be 3/4. It's got to be parallel. But for L2, we know it's going to be negative 4/3, the negative reciprocal, because in L2, here, we're looking for a line that is perpendicular. We also know that it goes through the point P. It goes through the point P. So that's our slope, and our point P is 2, negative 6. So using these two ideas, M1 equals 3/4, and the point P is 2 comma negative 6, we can go ahead and use point-slope form. You have a point, you have a slope, why not use point-slope form? Point-slope form tells me y minus y1 equals m times the quantity x minus x1. So again, notice x1, x1, y1, y1, m, there's my slopes. Now we want to figure out what this is in standard form, so let's multiply everything by 4. And this is really a positive 6 here, right? This is really a positive 6 because negative, negative. So when you multiply that by 4, you're going to get 24 equals. Now I'm going to distribute the 3 at the same time. But this 4 is gone because, again, I multiplied everything by 4. That 4 canceled and multiply by the 3 in both terms. We're going to end up with 3x minus 6. Now, at this point in time, we could say to ourselves, all right, I want to solve in standard form, so simply move things around. Let's go ahead and move stuff over. Moving the 3x over, we have a negative 3x over here, subtracting it. Subtracting 24 over here, we're going to end up with negative 30 over here, and this is plus 4y. And that's a fine answer. Negative 3x plus 4y equals negative 30. Your book has a tendency to want to use positive a values. It really does not matter, okay? So again, you could express this as 3x minus 4y equals 30 by multiplying everything by negative 1. So either of these two are a possible solution for part A. Let's take a look at part B. Part B is going to be almost the same, but instead of this slope up here, we're going to have the negative reciprocal of that slope. Part B wants the line to be perpendicular, so a perpendicular slope, if we know the original is 3/4, makes this slope m2 equal to negative 4/3. The point is still going to be 2 comma negative 6. So let's go ahead and take a look and figure out how to do this one. Y minus y1 equals m times the quantity x minus x1. Now all we have to do is multiply by 3 everywhere to get rid of this 3 in the denominator. So let's get rid of that 3. We'll multiply everything by 3 on both sides. Those 3's cancel. On the right hand side, we're left with this negative 4 and this x minus 2 quantity. Let's distribute that to become negative 4x plus 8. On the left hand side over here, minus a negative again, this is really y plus 6. Distributing the 3 becomes 3y plus 18. Let's add the 4x over to the left hand side, giving us 4x over here by adding it over. Let's subtract the 18. 8 minus 18 is negative 10. On the left hand side we have the 4x plus the 3y. So for this solution we have 4x plus 3y equals negative 10. And again, we can check the answers here by taking a look at the slopes real quick to make sure that they are indeed parallel and perpendicular. Your homework is from section 3-4 and a self-test on page 123.